Okay, so this recording is going to relate to Chapter 7D, which I know is a part of Week 1 work, but just from some feedback via email, we just need a little bit of help in understanding what the effective interest rate actually is. So I thought I'd go through that, and then I'll go through example 12 as well as a few questions that are in that part of the textbook to help us out. Now, you must excuse my probably not so great setup for this first recording. I'm just working out some kinks. It's a bit hard to do it in the classroom because of all the ambient noise, as well as when I'm on the whiteboard, I'm too far away so that the sound doesn't get picked up very well either. Doing it on the iPad is a little bit funny, so I'll continue to work on it, but I think we'll be able to get by. So first of all, what is an effective interest rate? So if you have a look in your textbook, the definition that they give you is the annual interest rate that would generate the same amount of interest with one single compound per year as that generated by the original loan. For some, that's quite a difficult definition for them to understand. So what I've actually got in blue here is my term as to how I put it. So essentially, interest rates do not reflect the effects of compound. So if I said a loan was paying 10% compound interest and monthly on a loan, that interest rate doesn't actually reflect what you'll get when we take into account the compounds. So the idea of the effective rate is that it reflects the real return. It takes into account the interest rate, but it also takes into account the compounding periods. So I'm hoping the first few questions that we do, it might make a little bit more sense too. But probably if you are having trouble with the textbook definition, write that down because I guess that's just a real basic way of putting it. So like anything, to find the effective rate, we have to use a formula, and this is on your formula sheet. So I might make a little note that this is on formula sheet. So we've got little I and then subscript effective. I don't mind if you just want to write a little I and then a little e is equal to bracket 1 plus I over n, bracket to the power of n, take 1, where n refers to the number of compounding periods. So that can range from being monthly, which is 12, to being quarterly, which is 4, weekly, which is 52. And then the annual decimal rate of interest. So it's really important that you've got it as a decimal. This formula doesn't work if you've got it as a percent. So I'm actually going to have a look at question 1 in the textbook just to give you a bit of an idea, first of all, of how this works. So question 1 in the textbook says calculate the effective annual rate of interest for the following nominal annual interest rates and compounding periods. Round your answer to 2 decimal places. So it's on page 306. Just pause it if you haven't got your textbook and you do want to grab it, and then come back and press play again. So like anything, I've always written down the information that I know. So I know it's 6.2%. And to make that into a decimal, I divide it by 100. So that gives me 0.062. The question says that it's compounding monthly. So that means my n value is going to be 12. And I might just pop in monthly there, just so we know how I got that value. Now the question's just asking me for the effective rate. So that means I just need to use this formula and the information I have to work out the value. So when I put in that formula, I substitute in my information. Now I get a pretty long decimal, and the question told me to round it to 2 decimal places. So I sort of did 2 steps in one. I rounded it to 2 decimal places and I converted it to the percent, which is 6.38%. And remember, in order to get a decimal back to a percent, we times it by 100. So it's just the opposite to what we did up here. Now, if you want to work through the remainder of question 1, it goes through a few more of those. But I'm going to jump the gun and have a look at question 2 because it starts to put into a bit of context what this is all about. So question 2 talks about Brenda. Brenda's a lovely lady and she wants to invest $15,000. Good for Brenda. She wants to invest it into an account earning 4.6% compounding quarterly. So the first question says, explain why Brenda would be better off with more frequent compounds per year. Well, the more compounds, the more money you earn. Because every time that money compounds, we're earning interest on that new amount. So if it was less compounds, well, we wouldn't have as many opportunities to increase that amount to earn interest on. So the more compounds, the more interest we earn. Now B and C is just getting us to calculate some effective rate. So this is just like question 1. Now I've gone and written down the information that I know. The only thing that changes is we're having a look at what happens when we compound it quarterly, what happens when we compound it monthly. So essentially we're trying to prove this statement. That's all we're doing here. So I've written the formula for both. I've substituted in the information for both, but I've just looked up here. I didn't put a 4 in, so I'll pop that 4 in. Now, when I go to enter this into my calculator, which I'll get you to do now, I'll just grab my little calculator, which is over here. Sorry, guys. Now we do get a pretty significant decimal straight away, so I'm going to round that to 2 decimal places, just like we would have done before. So I get 4.68%. Now if you like, feel free to put your decimal as one line and then your percent as one line, that's fine. Now if I enter it in for the second one as well, I get 4.70%. So anytime that I do ask for the effective rate, please give me the percent, because a rate is a percent, not a decimal. And that's what I'll be looking for. I don't know if I'd be cruel enough to take a half a mark off you, but conventionally, that's the unit that I'm looking for. So we have our 2 values. Now we want to prove, well, what does that actually tell us? And so the effective rate is higher when the compounds are higher. So that means the more frequent the compounds, the higher the effective rate is. And we can see that relationship right there. So we've essentially proved what we've said up the top here. Now we've got one example in this chapter, and I've actually done a fair bit to do with the example, but when you have a look at it, it's putting it into context in a bit more of a problem solving way. So we might have a look at that too, and I'll get you started on one of the questions, so then you can go away and work on them. I'll just open up the textbook to that example, so I've got it straight in front of me. So example 12, and it's on page 304, so I just might make a note of that. Awesome. So now we're talking about Brooke, we're not talking about Brenda, and Brooke would like to borrow $20,000. She is deciding between 2 loan options. One where she gets 5.95%, my bad. And that will be 0.0595. 5.95% when it's compounded weekly, so 52. So I'm going to pop in weekly. And option B, where it's 6%, so 0.06, and it's quarterly. So I just might pop quarters in here too. Now, first it wants us to calculate the effective annual rate of interest, and then it wants us to determine which is best. So you could nearly say this is a complex question because I'm getting you to compare 2 values that you calculate. So I've written the formula for both options and I need to calculate it for both too. So I might just change back to blue. So for option A, 1 stays the same, putting in my interest rate, and I'm dividing it by my number of compounds to the power of the number of compounds, minus 1. I'm going to do it on this side too. So 1 plus, now my interest rate is 0.06 here, over 4 to the power of 4, take 1. So if you've got your calculator handy, punch that into your calculator. And we'll get an assortment of decimals again, but that's okay. So 0.06126, and then over here, I got 0.06136, Now, I didn't show this step up the top before, but I'll pop it in here. To get the percentage, if I times by 100, that'll make sure I've got it exactly right. And I'm going to round to 2 decimal places. It didn't ask us in the question, but I might do it here. Or actually, no, I might even go to 3 decimal places, because looking at this straight away, they're quite similar. So I might go to 3 decimal places just so we get a more accurate answer. So if I times by 100, I'm going to have 6.126% here. And over here, I'm going to have 6.136%. So we need to have a look at which is the best option when she's borrowing money. Remember, she's not investing this money. So the lower effective rate will be better. Because remember, when we borrow money, we don't want to have to pay a lot back. So this is going to be the best option. Because to having a lower effective interest rate. Now, if Brooke was investing, option B would be better because we'd be able to earn more money. So keep that in mind when you're reading the questions. When we're borrowing, we want it lower, and when we're investing, we want it higher because we want to earn more money. Now, question 4 and 5, there's only a few questions to this chapter, but I wouldn't mind you having a look at them. I've gotten you started, so I've written down the information they have. The only thing additionally that you have to consider in this question is they want you to calculate the amount of interest earned. Now, when it asks you to calculate interest earned over 1 year, all you want to do is calculate or multiply your effective interest rate times the value of investment. Because when you think about it, I just want to know how much interest I earn. So it's interest of the investment. Therefore, this is my interest. Of refers to multiply. This is my investment. So that's just an additional little extra in question 4, and they do it in question 5 too. I hope this has been helpful. Remember, email me if you get stuck, and I'll be sending through another video shortly to do with the next chapter. Thank you.